All right, we're going to continue on with different data structures in R. Recall that we've talked about the most basic forms of data structures, beginning with the vector, where we learned about the different forms of indexing to access elements of a vector, and then we expanded that to matrices and then on to multidimensional arrays. And now we're going to talk about a more general form of a vector that's going to allow us to have more flexible definitions, and that's called a list object in R. And what this is, it really should be thought of as kind of this generalized version of a vector. The elements can be almost anything. Recall that for both vectors, matrices, and arrays, the elements must be all of the same class in R. That means they must all be numeric or all character or all integer, whatever their class is. Well, in a list, the elements don't need to be of the same type. They don't even need to be of the same dimensions. So we could have one element in a list that's a matrix, and then another element that's a character string, and so forth. We create a list by just naming our list arguments. So for example, I think the best way to begin is to see a list. Here we have the list command. We have our first element here, which is called num, and it contains a column vector 1, 2, 3. Then here's our second element. It has no label, but it is just the character string Nick. And then our third element, which is a matrix. So remember, diag will create a diagonal identity matrix of the dimension that you put in its argument place. So this will be a 2 by 2 identity matrix here. So when we look at the contents of X, and notice all of that is surrounded by parentheses and the list function call. And when we see the results, we can see, okay, here we have our column vector 1, 2, 3. Here we have our character string Nick, and here's our identity matrix, 2 by 2 identity matrix. Notice how we can reference particular elements of our list. Because we named the numeric vector here, we can use the $num here. We did not name the character string, so we have to use this kind of funky notation to get at the contents of that list element. You get used to this pretty soon. This is very specific to list objects in R. But notice it's just the same as how we indexed a vector or matrix or array, but we have to double the brackets. And then finally, because we named identity, we can just use the $. Okay, so elements, like we just went over, can be referenced in a lot of different ways. Here's some alternative ways. We already did the Nick, okay? Here, we could have referenced, instead of doing $num, we could have put num in quotation marks. This is identical to the vector, except with the vector or matrix or array, you just have the single square brackets. We already did that one. What would this give us? Well, look ahead first. What is in the third element of our list object X? Well, it's that identity matrix. And then we're combining or capitalizing on the fact that in this third element of our list, we have a matrix class object. So now we can use our matrix type framework for accessing something like, say, the first row. If I did, for example, and notice that's that first row, 1, comma. Okay, if I had done comma 1, I would have gotten back that first column, and it would have actually looked identical to this because they are identical. If I just do x1 true, it's going to create a sub list of those elements of our list object X. All right, so make sure that you're able to identify and retrieve all of these elements of this list array before you, list X before you move on. Now, we've talked about the apply function, and remember how it's a very useful function for use on vector-like objects. So whether it be a vector matrix or array, we can apply the same function over different margins of those types of objects in R. In the same way, we can use the function lapply to apply a function across each element of a list. and it will return your result also as a list class. sapply is pretty identical to lapply, but it's going to be returning your results as a vector or matrix. Sometimes you want the vector or matrix, sometimes you want it back in list form. vapply is also similar to sapply, but it has a pre-specified type of return value. We'll see an application of that later. Replicate will repeat the evaluation of an expression, and this is really useful when you have list objects and you want to replicate those lists. We'll see that in a moment. Unlist will produce vector of all the components of your list object, X. Length is going to tell you how many objects you have in your list. And when X is a list, I should point out. And finally, names is going to give you all the names of your list object, X. Again, this is a nice one to print out and maybe keep for handy reference. So let's see some applications. So remember, lapply will apply a function across all elements of a list object in R. So if we have 3 through 9, and we're going to create a list of 7 different vectors here. All right, so this object L, go ahead and run actually this object L and see what we get as a result. So now that you've had a chance to run this first command here that creates the object L, notice first of all, L is a list. You can tell by the structure. And what is within each element of that list L? Well, in that first element, which is surrounded by the double square brackets and has a 1 in it, you get 1, 2, 3. With the second element, you get 1, 2, 3, 4, all the way up to 1 to 9. Now note, nothing in here in this call to lapply is actually a list. 3 through 9 is a vector. Seek is a function. So since 3 through 9 is not a list, it's going to actually convert it over to a list. So each element of that list will be the length of that element in that resulting element in capital L. And so also note that when we apply the function seek, it's just going to apply it as if it's the list 1 up to n. So when we put in seek 3 for sequence 3, it's going to assume that we're going to make the sequence from 1 up to 3. And you can see that as the result in capital L. So now we want to compute the 5-number summary for each vector in L. Go ahead and see what you get and point out what is the difference or what is the same between using lapply, sapply, or vapply here. And notice the call to vapply is a little bit more complicated. All right, so to finish up with this part, I did run the lapply, sapply, and vapply here. Notice here that lapply, of course, gives us back a list object. We can tell by the structure of that printed output. When we use sapply, we get back a matrix. Notice that each column of the matrix is the result for the 7th part of the application of the apply function, okay, or the 5num function. Finally, vapply, it just creates a little bit of formatting over here for the rows so that we know that the first row are all the minimums and then the second row is all the first quartiles and so forth. Make sure that you can run those and that you understand the differences and how relative advantages of each.